Hey guys, welcome back. Last time we talked about the resolution of a screen, meaning the actual amount of pixels that a screen is physically capable of displaying. We established that a screen can have, for instance, a resolution, as in my case, of 1920 by 1080 pixels, resulting in 2.07 million actual pixels altogether that the screen is able to display. Today we're going to talk about the resolution of pictures, also known as the dimensions or size of pictures. Now let's see. Here in GIMP, which is one of the greatest photo editing or image processing softwares you can get for free. It's similar to Photoshop, except it's open source and it's free. Now, in GIMP, I have an image open that is 21 megapixels. That means in this picture, there are 21 million pixels. This translates to, in this case, in this picture, where we have an aspect ratio of 3 by 2, so meaning the width and the height, the proportional relationship between the two is 3 by 2. In this picture, we have 5616 pixels times 3744. So 5616 on the width edge and 3744 on the height edge. That's how many pixels are in this picture. If we go to our nice calculator, where do I have it? There it is. And we put in these numbers, then we're going to see that in this picture there are 21,026,304 pixels, also known as 21 megapixels. Let's say you have a Canon EOS camera. Then that camera might be a 21 megapixel camera. You might have a Nikon camera that's 21 megapixels. I'm sure you've heard of megapixels in the first place because that's how everybody is selling cameras these days. It's the big marketing terms. The more megapixels, the better, which is not even the case, but that's how they sell. Now, if you have a 21 megapixel camera, it's going to produce a picture like this, with this many pixels and with this big of a size in terms of dimensions. Now, we've talked about pixels, but I want to clarify for you for a moment what actually is a pixel. A pixel is a tiny, tiny dot in an image. So if an image has 20 something, 21 million pixels inside it, that means the picture is made up of 21 million tiny, tiny dots that are so close together that the human eye is incapable of perceiving where one dot ends and the next dot begins. I'm going to zoom in on this picture. We're going to look really, really close. And the closer we go, all of a sudden, we're going to be able to see the pixels. There they are. So a pixel is this tiny dot, or in this case a square. A pixel is actually always square shaped, but we call it dot. And it is a pixel can only have one color, so it's a tiny colored dot. And as I said, they are so close together that we cannot tell them apart. Now, what are we looking at? We're looking at this picture at 100%. As you can see, this picture is much larger than my screen can display because, as you remember, my screen can only display 1920 pixels in this direction and 1080 pixels in this direction, 1920 by 1080. But this picture is 5616 pixels wide and 3744 pixels high. So it is much wider and much higher than my screen is actually able to display. So only this small portion of the picture is going to be able to show on my screen. If I want to see the whole picture, I have two choices. One choice is I zoom out. This is what I did a little bit earlier. Now the size of the picture hasn't changed. The picture is still the same size. All I did was zoom out, right? You can see the zoom here is now at 18%. I can zoom back in. Now I'm at 100%. This is the actual size of the picture. The other thing I could do is I could scale the picture down. And that's what we're going to do now in GIMP. This is something we can do with any other image editing program out there. Some of the more popular ones, for instance, there's GIMP, there's of course Photoshop, there's Irfan View, which is a very nice image viewer for Windows. And then there's photo editing programs like Raw Therapy, Darktable, or Lightroom, which are able to export a photo at the size that you define. Now in GIMP, we're going to go ahead and we're going to go to the image menu and we're going to say, I want to scale this image. And I'm going to tell it, why not scale it down to 2000 pixels? And now if I press tab to go into the next one, it automatically changes the height of the picture to constrain the proportions, because by default, most image programs are smart enough to understand you don't want to squish a picture, you want to shrink it, but you want to keep the proportions the same. You still want it to look like this, only smaller. That's how, here in GIMP, for instance, you use this button here. If you want to explicitly tell it, no, I don't want to constrain the proportions, I want you to squish it, then you can do that. Constrain proportions can also be called preserve aspect ratio. Remember how we talked about aspect ratio? This is 16 by 9, my screen. This picture, the aspect ratio is 3 to 2. That's the proportional relationship between the width and the height of the picture. So that's what we want to preserve when we scale this picture down. 2000, and then it becomes 1333, and I already scaled this. So after I scale this picture, it is this large. You can see it's still larger than my screen, because remember, my screen only has 1920 pixels here, but this picture now is 2000 pixels. So if I scale it down even further to 1000 pixels, then we have this. We have 600 pixels width here, and we have 320 pixels width here. This is another picture that was taken at 12 megapixels, and you can see more of the picture is immediately visible because the picture is smaller. It's only 4240 by 2832. So that means my screen, even at 100% zoom, at the full original size of the picture, is able to display more of the picture. And again, we could also scale this picture down, right? Now, I've talked to you about scaling. We've looked at why or how we can scale a picture down. We've looked at image dimensions and what that means. And we've looked at what it means to have a whole lot of pixels in an image. Now, in the next few videos, we're going to learn why it is incredibly important to understand how many pixels, what the dimensions of a picture are. That's the most important metric for you to understand if your picture is going to fit whatever need you're going to, or whatever purpose you want to use it for. If you want to print it on a large piece of paper, you're going to need to have a picture that has more pixels in it, because otherwise, if it's just a small picture like this, you print it on a large piece of paper, it's going to look like that. That's bad, right? You don't want that. So that's why it's important that we have pictures that have a lot of pixels, or at least enough pixels for what you want to use them for. In the next video, we're going to talk about different file formats and compression, and then we're going to later go on about the intent of your picture, which I just talked about a little bit. Thank you for watching, and we'll talk soon. Bye.